The potential difference between two parallel plates, which are 3 millimeters apart, is 430 volts, and a proton is shot from the negative electrode at a speed of 1.6 times 10 to the 5th meters per second, as shown. The question is, what's the farthest distance from the negative plate that the proton reaches? So that is represented by a variable x here. So certain things to consider. For a parallel plate capacitor, the left plate or electrode is negative, and it's at zero potential, where the right electrode or plate is a positive potential, and it's equivalent to a maximum of 430 volts. Our problem is looking for this x. The way we would approach it is using conservation of energy, where kinetic and potential energy, final, this is electric, is going to be equivalent to kinetic and potential energy, initial. We have to recognize that when the particle reaches its maximum distance from the negative plate, it's going to stop. So your final velocity is zero, and therefore your final kinetic energy is zero. Similarly, when we start out at the negative terminal, your V initial, potential initial is zero, and therefore this one is also zero. This is all from your electric potential energy is related to potential using this equation. Therefore, if this is zero, your electric potential energy is zero, as is the case here. Your working equation is therefore your electric potential energy is really equivalent to your initial kinetic energy. And if we were to expand this, initial kinetic energy is 1/2 m initial velocity squared, and your left side is q and potential energy final. So we're really looking for x, and the potential at any point between your plates is related to these maximum potential by this equation, where x over d is bc. As you can see, if your x is equal to d, the potential is going to be bc. In this case, we don't have maximum potential because it's somewhere between the plates. If we substitute this here, we end up with q vf, I'm just going to rewrite it, equals 1/2 m v I squared, and our maximum potential, or potential at x, is x over d, bc equals 1/2 m v initial squared. Now we can see our unknown variable. X is therefore m v initial squared times d all over the product of q vc, this whole term denominator multiplied by 2. The mass here is mass of the proton, which happens to be positive 1.67 times 10 to the negative 27 kilograms. Our initial velocity is 1.6 times 10 to the 5th meters per second. Our distance of separation is 3 millimeters, or 3 times 10 to the negative 3 meters. Our charge is that of a proton, so it's a positive 1.6 times 10 to the negative 19 coulomb, and our potential maximum is 430 volts. If you plug in all your values here, you'll be able to solve for x, which is the farthest distance your proton will be from the negative terminal.